Hi guys, today I'll be talking about async in Python. And guys, this is a very important and useful topic specifically for AI developers. So I'll try to keep my lecture in context of AI developers and where can we use it and what are some considerations while taking care of it. So guys, it's not like that if you will hear about it once and you will see that okay, this is good, so you'll just use it everywhere. There are a lot of limitations and system design principles that you need to take care of. So we'll start slowly. So the first thing is guys, what is the difference between sync and async? So what usually happens, right, whenever we write Python code? So whenever we are writing any sort of Python code, what we usually end up doing is that we write sequential code. That means let's say you're defining a function called define print name, and what it is doing, it is returning a. Okay, now let's say by mistake you have not written the spelling of return correctly. Let me erase it. You have written something like return. Okay, and you have a big script that's down it. So if your this function will fail, essentially nothing below it would get executed. So by sequential code, specifically in terms of data science based applications, when you write sequential code, what you usually do is you have a loading layer, right, where you load the data up, then you might have a cleaning layer, then you have multiple pre-processing layers, right? Something which like you push the data to raw, you push the data to silver layer, okay, then you push the data to curated or gold layer. All this stuff usually happens in series, and it makes a lot of sense because see, what happens is that let's say without loading the data, how can you start cleaning it? Or if your data is not in a state of raw, how would you move it to silver? Because the same data asset gets transferred multiple times. But what happens is, specifically these days, what is happening is you would have heard about this async a lot. Even if you haven't heard, so that's okay. So there are two things which are very common over here. So one, the chainlet, on which a very soon tutorial that would come on my YouTube channel, that's for creating chatbots in Python, that uses it. And specifically guys, you need to understand that there are a lot of high level APIs or functionality as well, which in backend would use async, right? So I'm not sure how many of you are familiar with the web scraping. So nowadays a lot of people do web scraping via the uh, async HTML loader, which is provided by LangChain, and it works well. So the main thing is that like you can use the library, there's no issue, but if you would understand what async is, it's gonna be good for your general understanding, and I'll be explaining you like where are the use cases where we can use it as well. So now guys, let's just start with async programming only. Now we have had enough introduction. So quickly guys, in simple terms, the main concept is that you can have multiple tasks that run in parallel. So you don't have to wait for an entire task to get complete and then the next task would run. Okay. In sync, you would have to do that. So there are few terms which you would hear from people, and it's good to know them. It's not that everything you would use every time, but yeah, usually we use these type of terms. So in Python, you would be using simply an async module and doing all your stuff. It's not very difficult, but first time it might be a little difficult because the syntax is different. And whenever we see something new, so we might have to just like get it understand one. So there are few terms. So first term that you need to know is coroutine. Okay. Now I know this might sound that it's a big thing, but it's nothing. Okay, just consider for the time being it as an async function. Okay, so see guys, in Python you have functions, now you have async functions because obviously both cannot be same, right? So in simple terms, you can assume that async functions are nothing but coroutines. The next thing that you would see, and once you will see everything in code, everything would get super clear. The next thing that I want to tell you is await. So await is like, what await is going to do, it's going to be like, hey, stop, let other tasks run. So in your code, sometimes let's say you use this line, time dot sleep is equal to 2. So what will happen is that entire system is going to sleep if you are not using async IO. But here, if you will use await dot sleep, what will happen is, so if you will use await dot sleep, what will happen is that you could keep running other functions, but the function on which you have written, it would stop, and everything would be cleared by uh, examples. Just try to understand these terms because these terms are little important. The next thing that I want to tell you about is event loop. So guys, event loop is nothing like, event loop is a manager. Okay, so like you need something like a loop, okay, to like make sure that every function gets wrapped inside a context and it runs. Everything would be clear once you move into the coding part of it. So I'll explain you two examples. Okay, one is basic, which is like good to start with, and then I'll be showing you one other use case where I have used it, so that it would be a good understanding both on basics and practical layer. So let's just move to the coding window and try to understand what's happening. So let's just open our VS Code. So see guys, what we'll be doing first is trying to see this function. So just try to understand, we are importing async IO. So this is the module which allows you to do asynchronous programming in Python. So we are defining a function called make coffee. So guys, see, this keyword is important whenever we are defining something with the async of keyword. It would be considered as an async function. So we are printing starting to make coffee, makes sense, and then we are doing await async dot sleep too. So guys, see, now the thing is, it's not that my entire system would sleep. Okay, like if had I been using time dot sleep, which many of us use, the entire system sleeps, but our CPU is vacant, right? It can run other tasks. So why not we start making toast in parallel? Let's say you want to have a coffee and toast in your breakfast, and let's say you have put coffee for boiling. Meanwhile, you can work on other tasks, right? So you have started to make coffee. Now the system is going to wait for 2 seconds, but in the meanwhile, this function that is make toast would get executed, and starting to make toast, and now this is gonna like sleep for 3 seconds, and then your coffee would be ready and toast would be ready. So both of these tasks would be happening in parallel. So once you define this async function, this is called as a coroutine and async function, and essentially I'm using await to be like, hey, you could just stop this function, but that doesn't mean the entire CPU would die or it would be in rest state. It would run this function. And guys, this is the main event manager which I was talking about. So see how essentially we are able to use dot gather, and we are trying to wrap this function as well as this function so that everything could be synced, and this event manager you just need to run it. So guys, see, first time if you'll see the code you might feel a little overwhelming, but I think I've done a good job in making you understand. Let me quickly give you a quick recap. So see guys, async IO is the module that we would be using it. Then you need to start by calling in the async keyword and defining a function, makes sense. Then you just need to tell what your function is doing. Here we are starting to make the coffee, and then guys, await. So await is very similar to what time.sleep does, but it doesn't make your CPU like sit idle. Now this task would get executed. Okay, so your coffee is ready, but in the same process this task is also being executed, right? And the main thing is guys, the way you're defining functions is same over here as well. And this is the event manager. See guys, so you need to make some sort of event manager, right? Some sort of looping mechanism which would have like an orchestrator kind of a thing, which would have access to all your functions so that it could run everything in sync, and then you are just running it and calling the main function. So this is how you usually define the workflow. So let me run this code and you would see the output. So py test.py. So see guys, how and what happened. If you would just understand what did just happen is, we started to make coffee, and then the system went for 2 seconds sleep, but it isn't that it was dead. It started to make toast. See, and then your coffee was ready, and in the meanwhile toast was ready. So guys, this is very important. If you would see the synchronized version of it, right? Let me just make you see the synchronized version as well. That would just give you some sort of better understanding on what exactly is happening. Like you could draw a good parallel. So let's just see on the synchronized side of it. So see guys, this is like a synchronized function. Let me just copy this and let's just paste it over here. So guys, this is the synchronized function. Let me just run it. So see guys, here you are able to see what is exactly happening is that coffee and toast and everything was running in parallel, but here you would find that first I'll make coffee, then my coffee would be ready, and then only I'll start making toast. So guys, this is essentially called as like the upper part is async and the bottom part is sync. And guys, you need to choose which way of programming to do. I mean 90-95% case, if you're a data scientist, you would probably using sync only, because essentially, as I said, that your workloads are dependent. But I'll tell you where you need to use async as well as a AI developer. So guys, I think this example is clear. It just shows you that hey, this is how we used to do stuff, but now how we can do this stuff in simple terms. Only few terms you need to remember. One is async IO, that hey, this is the functionality that's going to be leveraged by Python to help me do asynchronous programming in Python. Then we just need to like use async in order to define a function, and an async function is called an coroutine. Then we need to just use this await async dot sleep. So this would just help the system to take some sort of rest, but this is not absolute rest. Your other function is gonna run once you wrap everything inside an event manager, and then you need to just run your orchestrator. Okay, so guys, these event manager orchestrator don't go by these fancy terms. It's just a simple way of telling that hey, this is a place where you need to keep everything at one side, and then you need to run the main function. Just understand it like this. Okay, so now this is done. Now the main question is that hey, this is it. Now let's just now we have understood that if we feel that hey, somewhere this can be used, so we can leverage, let's say, any AI tool in order to understand. But where do you think it could be used? So let's just pick up one use case. Okay, now consider the use case where you're trying to do sentiment analysis. Let's say you have five set of comments that needs to be classified as positive and negative. So one way is to use an LLM and make like 5 API calls one by one. So it would go in 1, 2, 3, 4, and 5. This is the sync way of doing it. The async way of doing it is that hey, my API limit, like what is the API limit, that is the number of requests my API provider allows me. So here I'm using Anthropic. It allows 50 requests per minute, so I can probably do 5 requests at once as well, right? So I could do that. So that will be achieved using async async programming, and I'll explain you why. So see guys, so what we are trying to do, I'll explain the code line by line. We are trying to import async IO. Good. We are trying to import the time functionality. We are trying to import .env. So guys, this helps me manage my .env file where I'm storing my API secret, and I'm importing Anthropic. So this from here I'll be using my LLM. So I'm loading the environment variables. Then guys, what I'm trying to essentially do is that I'm creating a client. I mean, this is very common practice, specifically if you're trying to like hit an API key or LLM, you would create a client. So see guys, now just try to see what is this semaphore. So guys, see, don't go by these fancy terms. It's just a feature of async where I'll be controlling the number of API calls. So right now I just want that 5 API calls should be made at once instead of one by one. Okay, I want 5 API calls to be made at one shot instead of, so this is the sequential way. I'll explain you this as well, and we'll be using async to make it all at once. So see guys, what we are trying to do, we have this classified text with sync. So this is the synchronized one. So this is the classification prompt, this is the LLM response, and this is the place from where we'll get the response, and we are calling it, and we just can run it. Okay, we just need to like write a for loop, that for prompt for I in our list of prompts, classify it one by one. So what it will do, it will hit API like 1, 2, and 3 and n times one by one. This is the sync way of doing sentiment classification. Now what is the async way of doing it? So see guys, this async way of doing it works like this. you just need to see the way you are defining function, everything stays same. It's just that I'm writing one more line, async with sem. So what this would allow me, this would just allow me concurrent processing. That means that I'll be making 5 API calls at once, because my API provider provides me a limit of 50. And then the next thing is that you need to understand is that we just need to just understand it on the context of 5. That means that we are just making sure that hey, all you can do is make 5 API calls at once. That is why this line of code has been written. It's just to control the concurrency, because I don't want that my system gets overloaded. So I just want to make 5 API calls only. Then see guys, rest of the code is same, like rest of the code doesn't change. Now just see how would I define my orchestrator for both sync and async. So see guys, for sync, as I said, it's not very difficult. You just need to call it one by one. But the main thing is for async. See, only thing you need to define is this. That is this thing. That you need to make sure that whatever tasks in hand, you're defining it inside a list. So this is just your orchestrator. And then you just need to call it, right? All you need to do is just call it. See, async results. And we are using await over here, so that, as I said, that await gives me the flexibility of making this function pause for a while, but other things can work in parallel. So let me just run this code, and I'll just make sure that you understand this. So leg.py. So see guys, how processing is happening one by one, but once I'm going to use asynchronous programming, how the processing is going to happen all at once, you would find that everything is going to come at once. So see guys, the synchronized version took 6.19 seconds and async took 5.73 seconds. This is not a very major difference, and I'll explain you a lot of times that why we shouldn't be even using async while we are making API calls to an LLM. Because guys, see, if we are asking for detailed response, right, then anyhow there would be latency. So if your response is very minimal, right, even this positive and negative shouldn't be a right approach. A right approach should be just asking it to render 0 and 1, so that your response could be quicker. Okay, so those are little high level things for the time being, but you could just understand that how async version actually reduced your programming. Like the sync version took 6.19 seconds and async took 5.73 seconds, and this is essentially the code. So as I explained you, all you need to just is understand few things, that just understand the workflow basically, and then you could leverage any AI tool or any website to generate code, because you don't need to remember anything. Always look for a good use case. So good use case is that, let's say I need to fetch weather details for 10 places, right? So rather than making 10 API calls, could I just like make one async call that would wrap those 10 calls inside one, and all of them would be executed at once? Maybe that is a better option. If your basically your output is not very not having a lot of text, so that your network latency is quick, you could use async back there. Then you need to define a function, like we have defined a function over here. All you need to do is just write it with this async keyword. And then guys, specifically for API limits, if you want to set a limit concurrency so that everything gets synced, you can just use your semaphore over here, so that we just control that how many API limits we are going to be making at once. And then guys, rest everything is same. Only thing that then comes is you need to define an orchestrator. Okay, and this is how you define an orchestrator. Okay, for specifically for async task. And then guys, you just need to call that async function, and always remember this await and everything just gets executed once. Like these are only to be used once you are using async programming. So see here, we have used await, right? So an async function would only guys use await, don't use it any other where. And just the main thing is that it's gonna make sure that other systems, other tasks can run. It is not like your entire function is dead now. Okay, so other tasks can run. Like here we were doing we are just making sure that the system sleeps for 2 seconds, but in the meanwhile you were able to see how the toast making process starts. So just look for use cases where it could be used. Specifically for me, I deal with a lot of APIs. So let's say I want to make an API call, like I want to make an API call, like let's say 15 API calls at once. So I could just maybe explore using async so that my response time is fast. But guys, usually like it's not that in specifically in data science AI ML workloads that someone would ask that, hey, why is this API taking a lot of time and stuff. But in case it is happening, you could consider using async. So just try to understand, guys. One thing is there that there are a lot of background things that happen. So for instance, if some of you are coding in Jupyter Notebook, you might need to explore something known as a neat underscore async, and there might be other environments which have other dependencies. So just make sure, right, on .py thing, this is gonna work amazing. So that's pretty much it, and have a great day. And guys, please subscribe to my YouTube channel, because all these concepts are very important. If you know these concepts and you move to the industry, then someday you would face them and you could explore that, hey, we could just use async programming. Hey, inside and single Python script only, what you could do is that you could use multiple LLMs, right? Let's say you're using GPT 4o mini, and you're even using let's say the Haiku. That is, both are small models. One is from OpenAI, one is for Anthropic. So you could say that, hey, if we have like 10,000 records, let's just distribute 5,000 over here, and let's just distribute 5,000 over here, and then let's just call 5,000 from one and 5,000 from one in an async fashion, and then combine the results. So guys, these type of things, in case you're working on systems that require great latency, so such kind of parallel design or system design might come into picture. But just start slow, just try to understand async, try to understand like how do you define an async function which is called an coroutine. Just try to wrap a couple, like to create 2 3 4 functions and wrap everything inside your event manager or orchestrator, and then just run it. So this is a workflow, and you would slowly understand. And guys, start leveraging AI tools in order to make your coding more efficiency, and just try to stay along with me, and please subscribe to my YouTube channel. Thank you, guys.